Building secure web applications is a challenging task. The threats and incidents we talked about before illustrate this quite well. But why is it so hard to build a secure application? It may be surprising to hear that the biggest obstacle is not technology, but our approach to security. More often than not, security is seen as an obstruction, an annoyance getting in the way of functionality and productivity. As a consequence of this attitude, security is often ignored until the very last moment. Many companies only do a final security check on a release candidate of the application. Consider the following scenario. Let's say we have built a beer-safe application from scratch and are ready to release it to the public. We want to be sure that it is secure, so we hire a security company to do a penetration test. This company will try to hack the application and discover security flaws. After the penetration test, we receive a report covering the discovered security problems. We can increase the security of our application by addressing this list of problems. After having done so, we release the application and hope for the best. Take a moment to think about whether this is a good way to approach security. Did you think of a few problems? Well, there are indeed a few drawbacks to this approach. What happens if the penetration test uncovers a fundamental problem? Addressing this may require us to redesign the entire application. How do we know that the penetration test covered all relevant threats? And did it cover the entire application or only a part of it? And what do we do in a couple of weeks when there's a new release? As you can see, only relying on a penetration test is not the optimal way to deal with security. That is because security is a process, not a task. The only way to build secure applications is by making security inherent to the application. The best way to achieve this is by implementing various security activities throughout the application's lifecycle. A first important step is to raise security awareness among developers. Every developer should have a security foundation to build on. Note that a developer does not need to be a security expert. Awareness about common threats against web applications is already a good starting point. Being able to recognize dangerous patterns is crucial to address potential security issues. This general level of awareness combines well with secure coding guidelines. These guidelines cover practical ways to mitigate certain threats. You can construct your own secure coding guidelines adapted to your development process. The list of best practices at the end of this course can serve as a good starting point. But there are also plenty of excellent documents in the public domain. Great examples are OWASP resources, which include various prevention cheat sheets. Before we go on, we will put all of this into perspective with an example. We will use SQL injection, which will be covered later in a lot more detail. For now, you should know that a SQL injection vulnerability occurs when a SQL query is constructed with untrusted data. If a developer is unaware of this problem, the application is likely to be vulnerable. However, having a security foundation enables a developer to spot the dangerous pattern. The secure coding guidelines prescribe the proper way to construct a SQL query with user input. As a result, the application will be more secure from the beginning. Running a penetration test afterward is still a good idea, to ensure that the implemented defenses hold up against real-world attacks. As you can see, each of these steps contributes to the security of the application. So far, we have assumed that the developer can spot a security problem in the code and address it. This process is implicit and only works for a specific set of threats. That is why it is recommended to adopt an explicit process to enumerate potential threats. This process is known as threat modeling, but also referred to as risk analysis. Threat modeling is a structured approach to list security threats against an application. It is applicable in various stages of the application's lifecycle. Threat modeling is based on a decomposed architecture or design of the application. The first step in the threat modeling process is to enumerate potential threats. Next, you assess whether the threats are relevant and significant. After that, you can define how to mitigate the threats in the application. The real power of threat modeling lies in its proactive nature. It allows you to reason about threats and defenses even before you have built the application. As a result, you can incorporate security into the core of the application's architecture. Here, we only covered the idea behind threat modeling. If you want to know more, you can check out the references at the end of this chapter. A final word about security activities in the application's lifecycle. We started this discussion by talking about penetration tests. Now you know that many other activities contribute to the security of the application. To be clear, a penetration test is a useful security activity. It helps verify if previous security activities have been effective. It also offers a different perspective and may uncover overlooked problems. But remember, a penetration test works best in combination with other security activities.